So now we're moving on to solving equations. So solving an equation means that we're taking a statement with an equals in it and trying to find the value of the unknown value. So when we're looking at linear equations, we're looking at equations with just an x. So because we've already done solving quadratic equations, most of this should be a breeze. So by the end of this, we should be able to solve linear equations with one variable, and those are pretty much the types of questions you were doing in Year 7. Linear equations with variables on both sides. So if there's x's on both sides and you want to bring them together, those were kind of like your Year 8-ish sort of type questions. And then linear equations with fractions in them. So again, like things that you've done before. So let's do a couple of examples. So firstly, we're going to solve the following. So when we're looking at solving an equation, we're backtracking, undoing any of the numbers on it. Again, one of the big things here is just being very careful with your positive and negative signs. So for this first one, we've got x on the right-hand side. We can just leave it there and we can still solve it. Otherwise, what you might want to do is just flip it over so that you've got x on the left and then you're moving everything towards the right. So it's up to you how you want to work with it. I'm just going to leave it like this, and I'm going to move the values towards the left. So the first thing I'm going to do is move the 3 because it's the furthest away from the x. So we're going to take off the 3. So you have 18 equals to negative 2x. Then your next step is to divide by negative 2. So then you've got negative 9 equals to x. And that's perfectly fine to leave as a solution. If you're okay with working with equations, you may not even need to write out the red steps. You can just write out each of those lines of work, each of your blue lines of working. Okay, so as a minimum, you should have that and that as part of your answer. If you leave it as negative 9 minus x, that's perfectly fine. If you want to, you can change it back to x equals negative 9 if you wish to. All right, with question B, the first thing that we need to do is expand that out. So 5m equals to minus 20 equals to 3m. Now again, a couple of ways of approaching this one. What we could do is we could take that 5m and subtract it over so that we've got all the m's on one side and the numbers on the other side. That's probably the most efficient way of solving this question. So we're going to take 5m off here. So it's negative 20 equals to negative 2m. And then we're going to divide by negative 2. So when we divide by negative 2, we get 10 equals to m. So that might be something that you might want to do. Another method would be, after we do the expansion, 5m minus 20 equals 3m. A lot of you might prefer to take the 3m and move it to the left. Okay, so like our normal equations. So when we move it this way, we've got 2m minus 20 equals to 0, because there's nothing left on the right-hand side. Let me just change the color. And then we can move the 20 over by adding it over. 2m equals to 10. Oh, sorry, equals to 20. So m is equal to 10. Okay, so that's another way you could do it. You had to do an extra step in that second version. Okay, so either one is fine. Again, you don't need to draw the arrows in. Okay, it's all like we assume that you know what you're doing when you're solving equations by this stage. So as long as you've got each of those lines of working where you're reducing the equation, then that's fine. All right, let's have a look at these ones. We've got a couple of fractions here. Again, there's a couple of methods that we can use to solve these. What I would do with this question is, because I've just got the pronumeral on the left-hand side, I'm just going to move all the numbers towards the right. So even though I've got a fraction on the right-hand side, I'm going to take the 5 and I'm just going to multiply the 5 over. Okay, just leave the right as a fraction. Okay, it's not going to kill us or anything to have a fraction in our answer. So 2a plus 4 equals to 10 over 3. And then we do all our steps as normal. So we're going to take off the 4. 2a equals negative 2 over 3, and then when we divide by 2, that'll give us a equals to negative 1/3. Okay, so for this particular question, because there's only one variable, it's quite easy just to move all those numbers towards the right. In question D, you can see that the two fractions are on the same side of the equality. So what we're going to do is combine those two fractions together first. Okay, so make it one fraction and then we'll start doing the equation work. So this is sort of similar to, you'll need to remember how to add and subtract fractions in order to answer this question. So we know that it's going to be over 6 equals 1. So on the first term, we had to multiply by 3, so we've got 9a in the numerator. The second one we multiplied by 2, so it'll be plus 2a, and that's equal to 1. 9a plus 2a is 11a. 11a over 6 equals to 1. Then we're going to multiply the 6 across. So 11a equals to 6. I'm going to divide by 11. So a is equal to 6 over 11. Hopefully those ones were okay. Let's keep moving. Now, question E. This question looks very similar to the one that just above it, question C. But the only thing is we do have pronumerals on both sides. So what we'd want to do here is one way we could solve this is first by making a common denominator, and then we multiply both sides by the same number. Okay, so if I make this one over 6, and this one over 6, then with the first fraction, we'll need to multiply the numerator by 2. And the second fraction, we multiply the numerator by 3. 3x minus 1. So if they're both over 6, what we can do is we can multiply both sides by 6, and all we've got left is 2, 4x minus 2 equals 3, 3x minus 1. What you notice is, if you have a look at this line compared to this line, can you see that this part here is the 4x multiplied by the 2, and the right-hand side is the 3 by the 3x minus 1. So sometimes we call this cross-multiplying. Okay, well basically what we're saying is if I've got two fractions with an equals in between, I can multiply them along the cross, and that's going to be equivalent. Okay, so that could be a slightly quicker way of getting into the solving of this equation. Then what we need to do is expand left and right. So 8x minus 4 equals 9x minus 3. Now when you're looking at these, I've got 8x and 9x. Often I'll choose to get rid of the smaller one, so I'll subtract the 8x across so that we're still ending up with a positive x. Sometimes it's just making things a little bit faster. So if I minus 8x over, then negative 4 equals to x minus 3. We add the 3 over. So negative 1 equals to x. When we come to question F, the two fractions are on the same side, so we'll try and make that into one fraction first. So we want numbers over 6. Again, be careful because it is you are subtracting the two fractions. Over 6, so 2n plus 1 minus 3 bracket 3n minus 2. And that's equal to negative 5. So 2n plus 1 minus 3n minus 2 is equal to negative 5. If we expand the numerator, 4n plus 2 minus 9n plus 6. Okay, again, remember, negative 3 times negative 2 is positive 6. Over 6 equals negative 5. If you simplify the numerator, negative 5n plus 8 over 6 equals negative 5. Now, all of those steps that we did in simplifying the fraction, if you can combine any of those steps together, you're more than welcome to do so. I've just shown you all of the steps that you'll need to do. Now let's get into the solving. So we're going to move the 6 over, multiply it, negative 5n plus 8 equals to negative 30. We're going to subtract the 8, negative 5n equals to negative 38, and then we're going to divide by negative 5. So when we divide two negatives, make a positive, so it's 38 over 5. And you can leave it as an improper fraction. Okay, you don't need to write it as a decimal or anything like that. Well, that's about it. There's quite a few there, and there's quite a few questions to do a bit of practice with as well. Okay, so again, making sure that we're getting on top of the algebra so that we're not making mistakes in this part of more complex questions.